Okay, so these are the topics that will be covered for today. So models of arguments, okay, and introduction to the scientific method. What is deductive methods? What is inductive methods? So induction with deduction, repetitions, pattern, and identity. So these are the uh, topics that will be covered today. So models of argument, okay. So in for the methodology methodology part, there are some models that can be used, okay, to explain about your methods. So this is like proof by demonstration, okay. So first, there are numerous examples of this approach being taken within the field of engineering. However, there are many reasons why this approach is an unsatisfactory model for research. The main objection is that it carries high risk, okay, because you are proving by demonstrating without any uh, theoretical explanation, okay. So you don't explain the theoretical part of it. So you just do the project and you demonstrate whether it's like working. Okay, this is like this kind of project is working. So for example, the artifact of may fail, okay, long before we learn anything about the conclusion that we are seeking for the support. Okay, so it is often that the case that this approach ignores the formation of any clear hypothesis. Okay, so you don't have any hypothesis. Okay, so you don't have any flow. uh, what is the problems, I mean, like, what is the theoretical gap that you want to solve, then what are the problems and what are the objective, okay. So you just come out with an idea and you just do and demonstrate it, okay. So this is a high risk kind of project or research work, okay. So this is one of model. So this may lead to lead the artifact to become more important to the researcher than that the idea that is intended to establish. Okay, so uh, you much focus on the uh, product or the project. I mean, like the end product, instead of the theories behind that, how it's actually working, hmm? How it is actually working, what kind of theories it is involved in that. So you just focus on the demonstration, purely on the demonstration part. So this the lack of clear hypothesis, okay, a lack of clear hypothesis. So lack of clear hypothesis need not to be barrier that it might be seen. The proof by demonstration approach has much in common with current engineering practice. So iterative refinement can be used to move an implementation gradually towards some desired solution. So the key problem here is that the iterative development of an artifact. Artifact here means your product lah. Your product in turn requires a method or structure. So we just purely focusing on the product itself instead of the theoretical explanation of that product. Let's say for example, you just simply come out with an idea, so and also a product without knowing how it's actually working. It's working actually, but you don't know the theoretical theory behind that. Okay, so in long run, if anything happen, any errors happens to that, you might not know how to solve that issue, because you don't know where the error is coming from, why it's happening actually. Okay, so that's the model that used can be said that proof by demonstration. So researchers need to carefully plan ways in which the fault found in one iteration can be fed back into the subsequent development. This is typically done through testing techniques. So you do the testing itself. Okay, uh, you do the multiple testing. You change that, change this. Okay, you might okay. We try and error. So it purely based on try and error. Okay, uh, so because you don't know how the, so let's say for example you're drawing a circuit. Okay, so you don't know how the circuit is actually working. Okay, so you try to change this and try, you're doing a try and error base, because it's like purely on the product itself, right? So you try to change this, and you try, so if it is not working, then you change to um, another components or what. Okay, so this is uh, we can say that not much strong enough, strong enough to prove your uh, project. Okay, research project, because for research we need to know what actually we are doing. So what kind of improvements, because as a master or PhD students, we are doing some improvements on the previous projects, right? So that's the main thing that we are focusing on. So in order to do the improvements, we just can't take that existing project and we modify something without knowing how it's actually working and what kind of modification we are doing. So we need to know what kind of modification that we are doing, we are inserting to improve that. Uh, so instead of like, instead of doing that, okay, instead of understanding the model or the previous project, we just take that project or product, we just try and error. Okay, so we do the try and error method, try to change this. Okay, and we try to get the improvements. We want to see the improvement, whether it's like whether we can get the results that we want or not. So it's a bit risky. It's okay. Is it like acceptable because you do some improvements, but it's very risky because if anything happens, it might it might work for a while. Okay, so but for example, let's say suddenly anything happens to that, it's not suddenly it's not working, so you might not know where the error comes from. Okay, so it is a bit risky lah for this kind of proof by demonstration. All right, so this is one kind of one model, one type of model that is not recommended. Okay, so another method is empirical proof by empirical method. So the Western empirical tradition. So this is what we actually use for the research purpose. So the Western empirical tradition can be seen as an attempt to avoid the undirected interpretation of artifacts. So it has produced the most dominant research model since the 17th century. Okay, so it can be summarized in the by the following stages. So this is the This is the methods steps. This is the model that is will be mostly used by the researchers. Okay, so first we start with the hypothesis generation. So this explicitly identify the ideas that are able to tested by the research. Okay, so as you know, we have the idea. Okay, so okay, we come out with the hypothesis. Okay, so how the project can be done. So this is the hypothesis creation. So then after that, we go to the method identification. So this is explicitly identifies the techniques that will be used in order to establish the hypothesis. This is critical because it must be possible for one's peer to review and criticize the appropriateness of the methods that you have chosen. So, the ability to repeat an experiment is a key feature of strong empirical research. So, so we have, let's say, for example, before that's why we have peer review. So, the requirement for in order for you to graduate as a master's or PhD student, you should have journals and also um, conference papers, right? So you should have some. You should collect some points. Why the requirement is made? Because you might have any idea and you might use any methods to do your project, but we might not know the project is the method that is used is correct or not. So that's the thing. Okay, so okay, so second is the method identification. So we have a strong empirical research on that, the ability to repeat an experiment. Okay, so this is very important. Then after that, result compilation. Okay, so as I told you, we come out with hypothesis, right? Then we do the literature studies. Then from the literature, we get the research cap. Then from the research cap, we identify the problems. Then to solve the problem, we come out with objective. Okay, your objective should solve the problems. Okay, so why are you doing this project? Because I want to solve this. Okay, so solve problem A, B, C. Three. Let's say, for example, you have three problem statements. So your objective is to solve that problems that you stated by you. So that's why you are stating the problems. If not, why you are stating the problems, right? So because you want to solve that, so your objective should be solving the problem, but with some scopes and limitations within that area. So that's very important. So then to solve what kind of methods it will be used in your project. So that is methodology part lah. Then after that, after coming out the methodology, you do the experiment, okay, data collection and data analysis. Then after that, you compile the results. So it will be discussed in the results and discussion part. Okay, this presents and compiles the results that have been gathered from following method. Okay, from the following method. So an important concept here is that of statistical significance, whether or not the observed results could be due to chance rather than observable effect. So This is for the results compilation. Then after that, we conclude. Okay, finally, the conclusions are stated either as supporting the hypothesis. Okay, it's not necessary. It's not necessary to support because we might not know the end results. Okay, so you might expect another different result, but it's turned out to be a different results. So it might be not supporting to the hypothesis. It might reject your hypothesis as well. So because this is research, right? So research can be anything. So in the case that results do not support a hypothesis, it is important always to remember that this is may be due to a weakness in the method. Okay, so it might be, okay, maybe lah, not necessarily must be. It may be due to some weaknesses in method. So if you are not getting the results that you want, then you have to check. As for my project, okay, I was testing again and again. I couldn't get the results. Then I went back to the theory. Okay, I went back to the theory itself. I tried to understand. I tried to calculate back. Then I identified that, okay, I need to change the formula. So I need to modify the formula so that I can get the results. So when I change the formula, I modify the result, modify the formula. Then when I use that formula in my design, then I can get the results that I want. Okay. So uh, so that's why you need to clearly, carefully identify whether it is actually uh, it is actually the problem in your method, or that's the results that you can get. Okay. So conversely, successful results might be based upon incorrect assumptions. Hence, it is vital that all details of method are made available for peer review. All right. So that's why the requirement of to graduate as a master's or PhD, we need to submit journal on conference paper, because your methods, whatever methods that you propose, whatever technique that you use in your project will be reviewed by the expert in that field. Okay, so they will identify whether the approach or the method that you use in this project is correct or not. Okay, and they will give comments on that. If let's say for example the scientific community, they can accept your method and approach, so whatever you the theoretical modification that you suggest, then it will be accepted in your accepted by the scientific community. Then you can put it in your thesis, you can publish it. Okay, so that's why we have to it is very important for the scientific community to accept your idea. Okay, your methods, that the technique that you propose, it is very important, because we might have any kind of idea, so we can propose, we can say anything. We can say, okay, I can do like this, I want to do like this, I want to use this method, this technique, that A B C. You can say anything, but we might not know it is actually correct or not. Okay, so only the experts, scientists, research scientists, professors, they only know, because they are in the field for like very for many years. Okay, so they only know whether it's correct or not. So if it is accepted by them, then we can say that, okay, your method is correct. Okay, so this is how the research actually works. It's not like shock sendiri. Okay, it's not shock sendiri. I want to do this. Okay, I can do like this. I can do like that. No, not like that. Okay, so you have to understand that. Okay, this is research. So the research we have scientific. We call them as scientific community. Scientific community are those who are in academics, professors, associate professors, those who are, they are the one in the scientific community who will evaluate your papers, whatever you write, whatever you propose, they will evaluate. So this is empirical method. Okay, so that this is the method that we use. Okay, so another one is mathematical proof. It is purely proving by mathematics. Okay, is mostly used by the mathematical programs lah. Okay, uh, like physics is purely maths, theoretical physics, we can say theoretical physics, um, like Einstein, he proposed the relativity theory, right? He already uh, proved in a mathematical way. Okay, mathematical way. He already showed there are 11 dimensions. Okay, so he already proved until 11 dimensions, and how the universe actually it's formed. Okay, the universe is formed in a relative way. So that is relativity theory. So it is mathematical proof actually, but the dissatisfaction with empirical testing techniques that has led many in the engineering research community to investigate other means of structuring arguments, okay, to support the particular conclusions. So for engineering research, uh, they will, it is much more stronger if they can include the uh, mathematical proof, as I showed you yesterday, because instead of using the techniques, so you can have a theoretical explanation on the techniques, but it will be much more stronger if you can prove it by the mathematical calculations. So the central idea of this work um, is that mathematics can be used to set up a system of rules about valid and invalid inferences. These rules can then be applied to work out whether or not a conclusion is valid inference given some initial statements about a program or some hardware. So I showed you yesterday, right? So whether we can actually, when I understand, actually when I do, I understand the theory. Okay, I understand the theory. So I try to use that theory to improve my uh, design. The basic theory, I know the basic theory, but it's actually there are some things that we might not know. Okay, so I had to go to the calculations part. Then I need to see, because I was using the basic formula, right? But then I understand that formula has to be modified so that uh, my hypothesis, because I proposed a hypothesis, right? I was proposed, okay, because I did my PhD, I need to have novelty. I need to have novelty, a new thing that does not exist before. Okay, so it is actually new. That is my hypothesis actually, right? So, but to prove that hypothesis, I was using the basic, I mean, like the formula that already exists. I understand that formula. So I used that, but I couldn't get the results that I want. So then after that, when I investigate, I try to look back at the formulas and all these calculations. Then I understand. Okay, I need to modify. I mean, like that. There are some modifications that need to be done So when I did the modifications, then I understand. Okay, then I can get the results. Okay, so then I propose a new formula for that. Here, right? So this part, okay. So I did all the analysis. Okay, I was proposing a new method. Okay, new method which is haven't done before. Okay, that method has not been proposed anywhere before. So I need to see all the formulas that involve. So I need to calculate back everything. Then I come out with a new formula. Okay, so the new equation. Then by using this equation, then I can get the results that I want. Okay, so uh, I continue with the next designs actually. Okay, because there are some some splits, right? Okay, from here, this is one antenna, right? Okay, it's directly connected. Okay, one port, it's as feed, right? So it's feeding uh, to the antenna itself. But when we include the second antenna, so there is some splits in here, right? So the splitting itself have some modification, need to be modified. So the formula has to be modified lah, because the current is splitting right here. So all these things have included and calculated. Then after that, this is where the theory is proved. Okay, so I need to explain in detail how it's actually working actually. Because I was using some components itself. Okay, components itself. So I need to explain everything in detail. Okay, so when I modify the length and width. Okay, so these are uh, the results that I get. Okay, so this is how uh, it's so it is good. It is good if you can include some uh, mathematical proof in your uh, work. So the central idea of this work is that mathematical can be used to set up system rules as valid and invalid. So the rules can be applied to work out whether or not conclusion is valid. Inference given some initial statements about the program or some hardware. Okay, so the field, um, it might not necessary for all the projects lah. If your project does not need, if like say for example those who are doing some algorithm modifications, right? So you might not need some the mathematical proof. Okay, for you, those who are dealing with some circuits, and also like for me, the antenna, it's all based on the mathematical calculations. So this field of mathematical reasoning in a research area, in its own right. It is, however, possible to identify two different approaches to the use of formal proof as a research technique in engineering. So for the first one is the argument of verification. The classical approach is to allow a human to interactively guide a theorem proving system towards some sequence of proof steps that be supported in the conclusion. So the problem here is that if the human cannot construct a proof, this does not imply that the conclusion is invalid. Okay, simply that they have failed to prove it. Okay, some uh, they might not know how the mathematical calculations I mean, like they can't understand, really can understand the calculation of the mathematics. So they might have failed to prove it using the mathematical steps. So another person might be capable of constructing the necessary mathematical argument. Okay, so another one is the argument of refutation. So rather than attempting to prove the correctness of an argument, this approach attempts to refute it. Typically, this is done by setting up a description of the intended system behavior. So instead of proving it by mathematical explanation, so you can setting up a description. Okay, description. So you describe how it's actually your product or the circuit or is looking. So model checking tools then automatically explore the state space of the proposed application in an attempt to find a situation in which the desired conclusion does not hold. The attraction of mathematical proof techniques are very strong. Okay, so if you can include some mathematical proofs, so it can be considered as very strong because you have very strong foundation. Okay, so they provide a coherent framework for analyzing research questions in engineering. So they also explicitly state the criteria for invalid inference, for valid inferences, as well as the environmental conditions that restrict the scope and applicability of the reasoning process. Okay, so however, many problems that limit the utility of this approach as a general research tool. The first is that incredible care needs to be made over the interpretation of the results from the mathematical proof. Okay, so mathematics, as you know, it's very crucial and very complex, especially for the engineering mathematics. So you need to be a very it might take time. It might take time because you need to understand how the um, uh, how the formulas are working actually. Okay, then after that, from there you have to identify what kind of modification that you need to do in that formulas so that you can get the results that you want. So some mistakes, even one a small small mistake in your calculation might give a very a wrong result. Um, so that's why it's like people are very uh, it's like worried to use that mathematical proof. So that's the thing. Lor. The second problem with formal reasoning is that their scope is limited. Okay, interactive and critical systems pose especially challenges for the application of mathematics. So the third problem is related to the cost of applying formal techniques. So it takes a long time to acquire the necessary skills. So as I told you, um, it might take a lot. I mean, like you need to be very patient uh, in understanding how the theory actually working. Okay. So you need to try to understand. You need to try a lot of calculations. So even for me, it's actually took, I think, maybe 3 to 6 months to solve that, solve the mathematical mathematical things. Mm, okay. Maybe around 4 months, I think, because it's maths, right? So you need skills. So we need to practice back the engineering mathematics to understand how the summations and all these things works. So there might be some uh, the engineering formulas that we used. Okay. So this is what so you might have some differentiation. You might need to use differentiation. You need to use the summation formulas. So that's the thing. It will cost you um, to take a long time lah, to solve it. So similarly, it can take several months to conduct relatively simple proof for medium and large scale application. So it might take several months for me. So like for me, like I think 4 months. I think 4 months to solve that. Only that the mathematics part actually, because for PhDs, for masters it might not critical, but for PhD, it's actually we are proving a new thing. So we are coming out with a new idea, right? So since we are coming out with new idea, so we need to actually prove that it's actually working. Our idea is working. So since for my case, I need to go back to the formula itself to prove it, because I was trying to modify the design itself using the basic formula. So since the basic formula does not work, so I need to go back to the formula, and then I need to understand. I need to try to understand everything. So the modification part itself will take time, because you need to know uh, which one is you need to modify, right? Because a lot of things, and let's say for example, okay, so there are a lot of parameters that involve here, right, in this formula. So a lot of parameters that involve, so you need to know which one to modify, whether this one or this one, this one or this one. Okay, which one you need to modify? You want to is it like you need to plus 2 or 3 or 4? Okay, so you divide by 2 over this. So do we need to modify this part, or do we need to modify this part? How you will identify? So you need to have a good mathematical skill so that you can understand and you can modify that, right? So it might take time actually to prove it. That's why you need some patience on that. So it is important to recall that the failure to prove hypothesis was a valuable resource for empirical techniques. So exaggerated claims have been made for formal reasoning, typically not by the researchers themselves, and many of them claims have been falsified. Okay, so you can claim, okay, I can prove this by this formula, but many of these claims have been falsified. They have identified that it's actually not correct. Okay, so these are the models, uh, models of arguments that can be used in research. So usually, so for research, okay, for research we use this empirical method. Okay, so we follow the uh, we follow hypothesis generation. Then after that, we come out with the research gap, then problem statements, objective, scopes and limitations. Then we go to the methods. Okay, from methods uh, we do the analysis. Then we get the data. We analyze the data. Then we come out with the results and discussion. Then we conclude it. This is empirical method that we use. So if it's if you can use a mathematical proof to prove your designs, it is very strong. Your research will be very strong. But there are some some problems. Okay, involves this. Okay, so it might take time. So you will need some patience and also some exaggerate claims. Okay, so you might claim a false theory, false mathematical proof. So that's the issues that is raised in this kind of arguments. Right. So we'll take a short break. Okay, then we'll continue back at 3. Okay. Okay, so far is it okay? You're good.
Yeah, but
All right. Okay, so I'm going to back. Okay, so next is the so before I go to topics, do you guys have any questions? So you guys understand, right? Just now I was telling proof by demonstration and also empirical method, and also the theoretical mathematical proof. So for research, what kind of method models that we use? Who can say that? Arvin? Arvin, are you there?
Yes, sir.
So for our research, what kind of models that we use?
Models.
Yeah, we learn about the models of arguments, right? That's all. Three
Yes,
models.
sir.
So what are the models that we use? Whether is it like a empirical model or mathematical proof or proof by demonstration?
So I think mathematical and demonstration will be enough.
Okay, so empirical and mathematical. So any others? Have any other suggestions? So for research, we use empirical method, right? Models of arguments. So that's what we focus on. So starting from the hypothesis, then um, demonstration. Why demonstration, no, Ratika?
Sorry, Doctor.
Why you saying, yeah? Why you said demonstration?
No, I think I just apa the demonstration is one of the type of the models of argument.
Oh, so is it recommended that you use that?
No.
Okay, so you can use that, but it's lacking lack of theoretical explanation with that. So for research, we use empirical models of argument, and also if can, we try to include the mathematical proof as well to make it to make your research much more stronger to prove. Okay, so that's the thing. So next we go to the next part. So introduction to the scientific methods. So we have theoretical methods, empirical methods, which is on the experiment part, and also we use some simulations. Okay, on the computer. Using the computer, we can do some simulations. So theoretical method, we have theoretical method uh, create formal models. They define concepts within these models, prove properties of the concepts, abstraction, high details to make the whole more understandable, and to make it possible to prove properties of it. So theoretical methods provide proofs of properties by deductive methods. So we'll study what is deductive actually. So this is one of methods that we can use for our in our research. Okay, theoretical method. So empirical methods, as we saw just now. So we perform experiments using empirical methods and see how it's turned out to draw the conclusions. So we do some experiments, right? By using we do some fabrication. So we come out with the design, we fabricate, and we do the experiment. Then after that, we collect the data and we analyze the data. So this is one of the method. And also before doing it experiment, I mean, like, we fabricate the real product. We can do it in computer. We're using a simulation softwares. So there are a lot of simulation softwares available for different uh, kind of programs. Okay, like for example, for like communication electromagnetic simulations, we have a lot of softwares available. So using that software, we can design, we can model it. Then after that, uh, we can see the results before we actually fabricate into a real product. Okay, then after that, we fabricate the real product. We do some experiments, measurements. Then we collect the data. Then what we do, we'll compare with the simulation results and also the real results. Okay, so we need to remember that the real results is actually the one you fabricate. Okay, you fabricate, and when you measure, you get the results, right? So that is the real result. So you have to compare with the simulation. So you might have you might miss something in your simulation. Okay, so you need to, because the real product is the one you actually fabricate. I mean, we will be using the real products, like right, like phones, laptops. It's all real products. Okay, so if you get the results from the real product, so it is what you actually get. Okay, so if you compare to the simulation results and it is not tally together, it's not tally. So you might need to see the simulation. So there might be some mistakes in your simulations. So you need to modify it. Modify. Then after that, you need to compare it back with the real product. So here we start with a formal model at some easy to understand level. Make artificial experiments in a computer. So collect statistical and draw conclusions. So next, so we'll see deductive methods in engineering. We have two types of methods, which is called as deductive method and also inductive method. Okay, so what is deductive methods? So ordinary mathematical proofs. So often finite entities defined recursively, properties proof with induction, but also reasoning about limits. Go to the limit when infinite behaviors are modeled. So this is ordinary mathematical proofs. Okay, so encoding and translations common in complexity theory, sometimes also more conventional mathematical techniques. So this is like a very ordinary mathematical proof. Okay, so next is inference system and their applications. So what is inference system? So direct modeling with logical inference system, common in semantics programming language. Okay, proof methods from logic. So proof about proofs. This is like common for the programming languages. You have a lot of algorithms. We use different algorithms on different languages, right? So this is common for the programming languages. So next is inductive method. So mathematical induction. So it is important to make a clear distinction between empirical induction and mathematical induction. So in the empirical induction, we try to establish the law. Okay. In the mathematical induction, we have the law already formulated. Okay. So you need to understand. Okay. Empirical induction, we try to establish the law. Okay, we are trying to create a new law. Okay, but in mathematical induction, we already have the law, the formula already existed. So we're trying to prove that it holds generally. This is for mathematical induction. So the basis of mathematical induction is the property of the well ordering principle for the natural numbers. So this is what is mathematical induction is about. Right. So you need to know it's like for the empirical induction swing, we are trying to establish a new formula, okay, from the scratch itself. So we try to modify it. Okay, we try to modify the formulas and we try to prove it. But mathematical induction, we use that formula. So which is already existed. We try to prove that using that formula. There is difference between empirical and mathematical. So the principle of mathematical induction. So this is an example. So suppose Pn is a statement involving an integer n. Then to prove Pn is true for every n more than n0, it is sufficient to show these two things. So to prove it, so this is mathematical induction because the formula is already exists, right? It already exists. So we just want to prove this. So Pno is true for any k more than no. If pk is true, then pk plus 1 is true. So a proof by induction is an application of this principle. So we use this to prove it, whether the statement is correct or not. So the statement is Pn is true for every n more than n0, right? So we are trying to prove it. Okay, we are trying to prove it with this by applying this. So in the induction step, we assume that statement is true in the case n is equals to k. Okay, and we call this assumption in the induction hypothesis. Okay, so we assume that n is equals to k. Okay, so this is a difference between mathematical induction and also empirical induction. Okay, so for mathematical induction, we are trying to prove that the formula which is already existed. Okay, for empirical method, we are trying to establish a new formula, or we are trying to modify the formula and try to prove it. Okay. So induction versus deduction. Okay, so which one is we want to see what is the difference between inductive method and also deductive methods. So there are two types of methods, right? So the main difference between inductive and deductive reasoning is that inductive reasoning aims at developing a theory, okay, while deductive reasoning aims at testing an existing theory. Okay, you should understand. Inductive reasoning. Inductive reasoning means it's aiming to develop a theory. So if you want to develop a new theory, you want to come up with a new theory, new formulas. Okay, so we call it as inductive reasoning. But for deductive, the theory is already exists, so you want to prove it. Let's say, for example, I come out with a new theory. Okay, I develop a new theory, and I already publish it. So the next person comes, he read my thesis and paper. So he want to prove it, that existing theory. So it is called as deductive reasoning. So in other words, inductive reasoning moves from specific observation to broad generalizations. So deductive reasoning works on the other way around. So both approaches are used in various types of research, and it's not uncommon to combine them in your work. Okay, so you can combine both inductive method and also deductive method in your research lah. So that's the thing, that's the part that you need to understand. So for inductive, okay, so for inductive, as we see just now, so inductive is developing a theory, okay, while deductive is testing a existing theory, right? So specific observation. So is for inductive, you do some specific observation here. Then after that, you recognize the pattern. Okay, so you recognize the pattern, then you come out with the new formula or a new method. Okay, and you try to prove it using your mathematical skills or your theoretical understanding, right? So then after that, you do a general conclusion. Okay, so then after that, what you do, for this is for inductive, this is for inductive. So now for when you already come out with new formula or new methods, so means that it's already the theory, when you prove it, okay, and it is accepted by the scientific community, saying that okay, this theory or this formula is true and incorrect. So it means that it's already existing theory when you publish, so it's become an existing theory. So when the next person comes, okay, so using that theory, using that formula, so he formulate a hypothesis. All right, so he formulate a hypothesis, then after that, using that empirical method, okay, so he do all the I mean, like how to say, he do all the research, right? He do all the research. He come out with the he do all the literature studies, then he come out with the research gap, then after that, using that, he come out with the problems objective. Okay, so that's the thing lah. So after that, using that formula, he collect the data, then after that he analyze the data. All right, then after that, so he can say that based on the results, you can do the conclusion whether the hypothesis got rejected or accepted. Okay, so so based on this, okay, so based on this, so based on this, you can when a person when a person do all the analysis, okay, based on the existing theory, collect data and analyze data, okay. So based on this, another person, okay, another person can come. It can based on this conclusion, he can come out with a new thing. I mean, like he can do the specific observation from here, okay. So that's why we call this as a research. Research means that you are searching again and again and again. So that's why it is called as research. No? So when you conclude the hypothesis, so using that conclusion, another person can come. He can do some specific observation. Then he can either he can do the deductive method analysis, or he can do inductive method analysis. Okay, so we can it can be like for master students. Usually they will go for this deductive method lah. They just using the existing story, they just want to improve something, right? So they will usually use this deductive method. But for PhD students, using this, they will using the observing conclusions. They try to come out with a new thing, a new method or new formulas. Okay, they try to prove it. They usually go for inductive reasoning, so that they can propose a new formula or new theory based on the observation. So it's all related to each other. Okay, inductive and deductive are related to each other. Just that the way the research is conducted is different. So for deductive is like analyzing the existing theory, okay, and you just improve the existing theory. You try to prove the existing theory, and you try to improvise the existing theory. All right, but for inductive, you will come up with a new method or new formula. So both are important. Because the improvement, the deductive method will give improvements. Okay, improvements. Whether, however, the inductive it will give innovations, the new innovations. So that's important. I mean, like both are important. Inductive and deductive reasoning are both important for the research. So when there is little to no existing literature on a topic, so it is common to perform inductive research. Okay, so if let's say, for example, there is no much literature available, you have some idea, but there is no much literature available on the topic that you want to do research. So usually it is common to perform inductive research because not much literature is available, right? So because there is no theory to test actually. So inductive approach consists of 3 stages, right? So we have observations, a low cost. This is like, for example, this is an example. So a low cost airline flight is delayed. Okay, dogs A and B have fleas. Elephants depend on water to exist. So you don't know. You want to do some research, but there is no any previous literatures that have been done before. So what you do, you observe. Okay, so first thing is observation. Then after that, seeking the patterns. Okay, so another 20 flights. So first, a low cost airline flight is delayed. Another thing, seeking the patterns. So you keep on observing and you see the pattern. Another 20 flights from low-cost airline are delayed. All right. All observed dogs have fleas. All observed animals depend on water to exist. All right. So developing a theory. Low-cost airline always have delays. Okay. All dogs have fleas. All biological life depends on water to exist. So this is like preliminary conclusion lah. All right. So limitation of inductive approach is when a conclusion drawn on the basis of inductive method can be never fully proven because um, uh, the existing research is not very strong in that area or topic. So we cannot say that whatever we conclude, whatever conclusion that we made is actually is actually correct or fully proven. So, however, it can be invalidated as well. So, example, you observe 1,000 flights from low-cost airlines. All of them experience a delay, which is in line with your theory. However, you can never prove that the flight one, the next flight will be delayed. Okay, so you cannot never prove that the next flight will also have a delay, right? So still the larger data set, the more reliable your conclusion. Okay, so that's why we can say that we cannot fully prove with your using this induction because this is a very new theory, right? New formula that you come out with. So that's why we cannot fully prove it. So deductive research approach. So when conducting deductive research, you always start with a theory, okay, with a new theory. So the theories which is already given, okay, just now for the inductive, just now we did the inductive research, right? So this is the low-cost airline. So low-cost airline always have delays. All dogs have fleas. All biological depends on what exists. So using that theory, okay, taking that theory from the inductive research, then you do a deductive research. So reasoning deductively means testing these theories. Okay, so testing, you want to test the theory, right? So let's say, for example, I already come out with a new theory, new formula. I already do some designs based on that. Okay, so I already get some results, then already get published, right? So next person, when he wants to come, when he sees your theory, okay, you want to test the theory. Okay, so remember that if there is no theory yet, you cannot conduct deductive research. So you should remember this, right? So you cannot conduct a deductive research. Then to conduct a deductive research, you must have existing theory or existing formula. So then only you can do a deductive research. So the deductive research approach consists of 4 stages, right? So start with an existing theory and create a problem statement. So using these existing theories, okay, so we have 3 theories that this is an example. So low-cost airlines always have delays. All dogs have fleas. All biological life depends on water to exist. So now we do a deductive research. So low-cost airlines always have delays. So we using the existing theory. So all dogs have fleas. All biological life depends on water to exist, right? All right. So after that, what we do, we formulate a falsifiable hypothesis based on existing theory. If passengers fly with a low-cost airline, then they will always experience delays. All pet dogs in my apartment buildings have fleas. All land mammals depends on water to exist. Then after that, what we do, we collect data, right, to test the hypothesis. So collect flight data of low-cost airlines, test all dogs in the building for fleas, study all land mammal species to see if they depend on water. So analyze and test the data. Okay, 5 out of 100 flights of low-cost airlines are not delayed, right? So based on the data, we can say that 5 out of 100 flights of low-cost airlines are not delayed. 10 out of 20 dogs didn't have fleas. All land mammal species depend on water. So these are the analysis that we get from the collected data. Okay, so this is why analysis is very important, so that we can come up with some results based on the data. So now what we do, we conclude it. We conclude, we can make some conclusion whether to reject or accept the hypothesis. So 5 out of 100 flights of low-cost airlines are not delayed. So we can reject the hypothesis. 10 out of 20 dogs didn't have fleas. So we can reject the hypothesis. So all land mammal species depends on water. So this is supporting the hypothesis. So for inductive research, we don't have any theory that to test, right? So we do some observation, okay? We seek the pattern, okay? Then after that, we develop the theory. So once we already develop the theory, for deductive research, we can test the theory, whether the theory or hypothesis is correct or not. So limitations of deductive approach is that the conclusion of a deductive reasoning can only be true if all premises set in the inductive study are true and the terms are clear. Okay, so it is very important. The deductive approach only can be true. Okay, only can be true if all the premises set in the inductive study just now. So if there is any mistakes or any incorrect formulas or theories that is included in this the previous inductive research, then it might affect the deductive research as well. So it is very important for those who are doing the inductive research, coming up with new theories. Okay, but mostly, even like PhD themselves, they just they're not coming out with new theories because it will take much more time. A lot of times, because we have limitation, right? We have limitations, right? Time limitations, time constraint, and also cost constraint. So it's very rare for those who are coming out with a new theory. They just come out with like they try to modify the existing theories, okay, to prove their hypothesis. So then we can do the deductive research on that. Okay, so that is induction with business deduction. Okay, so for induction, you have to know inductive reasoning is coming out with a new developing a theory, while deductive reasoning is aiming at testing the existing theory. Okay, so it's always related to each other lah, both induction and also reduction. Okay, so far do you guys have any questions? Guys?
No, sir.
Okay, all right. All right, so this is for induction and reduction. Then we will see repetitions, pattern, and identity. Okay. So what is repetitions? Repetitions and pattern. What's that mean? You can make your model more complex and more faithful to reality, or you can make it simpler and easier to handle. So only the most naive scientists believe that the perfect model is the one that perfectly represents reality. So it is uh, because, like for example, uh, we can propose a theory or any designs, but we have to make sure that whatever we propose, okay, whatever we propose, it should be perfectly represent the reality. If it is not logical at all, it is not practical, the practical to use in reality. So it is very difficult for you to prove your project is actually worth. So that's the thing. Empirical methods relies on observation and experiments, which lead to a collection of data describing the phenomena. In order to establish a pattern or regularity of behavior, we have to analyze, compare the results, data that we collected, searching for similarities, repetitions, and differences. So we usually will collect data based on the experiments, right? Experiments that we do. So we must be able to analyze the similarities and differences on the data that we collect. Okay, so that's very important for this for our research. So all repetitions are approximate. The repetition b of an even a is not identical with a, okay, or indistinguishable from a, but only similar to a. As a repetition based on upon similarity, it must be relative. Two things that are similar are always similar in certain respects. So you need to know the difference between the repetitions and also the pattern. Okay, so two things that are similar are always similar in certain respective aspects. So here you can see we find that some of the figure above are similar with respect of shading. Other are similar with respect of shape, and some are similar with respect of edge or size. You can see here, these are is round, right? But this one also round, and this one also round. But you can see is the pattern are the same. Okay, uh, it has round shape, right? It's shape the same, shape is same, but you can see there are shades, right? So if you see the shade, you can see this one have shade, and square box have shade, and this is triangle, this one have shade. And if you observe the color, right, the pattern here, so inside got dot, here got dot, and also have similar color from here. So this one also same. This is all triangle, right? This is triangle shape. But if you observe carefully, you can see there are some differences. But it is same with other patterns. I mean, like other shapes, right? So if you see here, this is similar with this and this, right? You can see triangle and this one, this shape, right? So these shapes are same. So above diagrams illustrate the point that things may be similar in different respects, okay, and that any two things which are from one point of view similar may be dissimilar with another point of view. So as I told you just now, we can say that from here we can see that it might be similar based on the shape, okay. So it is all round shape, but it has some differences, okay. You can see this is have shade and this one does not have shade. So from one point of view you can say this is all a round shape, but in a different point of view you will see this round shape has shade and this square shape has shade, and this is triangle shape has shade. So this is what you have to know about the repetitions, how repetitive the similarity between one shape and another shape, okay. So generally similarity and consequently repetition always presuppose the adoption of a point of view. Some similarities or repetitions will strike us if we are interested in one problem, and others if we are interested in another problem. So let's say for example for our research, it's based on from which point we are looking at that at your project at the problem, okay. So the problem from one point of view have different conclusion, okay, different hypothesis, but from different another point of view it might have different hypothesis. So that's very important. It is very careful, it is very crucial for a researcher to identify the similarity and also the pattern from of the problem, from what kind of point, what kind of view that you looking at into the problem. So generally so some similarities, as I told you, some similarities or repetitions will strike us if you are interested in one problem, okay. So and others we have interested in other problem. So searching for similarities and differences leads to classification. So the division of objects of or events in different groups and classes. The simplest tool for classification is the binary opposition and dichotomy dualism. So when we use dichotomy, we only decide if an object is of kind A or of kind B, or uh, inverse of A. So example of frequent dichotomies are yes or no, true or false, before, after, more or less, above or below, right? So these are the differences you can use, right? So identity. Next is identity. The basic feature of experimental method, it's reproducibility. Um, reproducibility. So it must be possible to establish essentially the same experimental situation in order to obtain the same results. So what we call essentially equivalent, or we can call it essentially the same, depends on the situation. So even here, the principle of information hiding help us to get a practical or level of resolution. So which means that information hiding for all the objects below that level. So when we use so this is like repeated. So for example, assume the atoms, okay, that assume that atoms, a certain kind of under well defined condition, are in practice identical as well as their constituent parts. In fact, it is true as long as we are not interested in the structure of certain type of atom. So in our focus, it's on the specific features of an atom. We will find that each atom of a certain type is a complex system of particles. Okay, we have protons, neutrons, electrons that can be in different energy states or different spatial organizations. So the basic thing is the basic of the property of an atom is proton, neutron, and electron, right? But the arrangement of that protons, neutron, and electrons gives a new material. Okay, whether it can be uh, uh, natrium, okay, a zinc, okay. So the arrangement of the protons and neutrons and electrons will decide what kind of material it will be. So declaring two system particle states and as identical is entirely matter of focus. Okay, so we have to clearly focus whether these are identical, or there are some differences. Okay, so it is very important for you guys to know. Okay, repetitions and patterns. Okay, repetitions and pattern. You should know whether the pattern has more similar type of shape. For this example, I'm showing the shapes lah, as an example. But in your case, you can see the pattern, the repetitions, and the pattern. Okay, you're collecting the data, right? The data. So when you put into the graphical view, okay, when you put into a graph, okay, so you can observe the pattern of the graph itself, whether it is repeating, okay, it has similar shape or different shape, okay, different types of pattern or different type of pattern. So this is what it is between the repetitions and patterns. Okay, and also the identity means is identical. Okay, identical means it is similar. So you should have a very high focus, okay, to make sure that the results that you collect, I mean like the data that you collected, has similar pattern. So this is then if it is as the similar, I mean like both are same, you can say that both are same. So you can say that it is identity, is identical to each other. All right. So this is what it's all about. Okay. So I think I've already concluded for this topic. Okay. So any questions so far? Any questions so far? Guys?
No, sir.
So far you understand, right? Okay. So it is important to know how to conduct your research project. Okay. So whether you want to, so for us, for research, we use empirical method lah. Okay, this is the method. So because we have to know, you can't simply do your research based on your own knowledge. Okay, there is a, you should follow a correct way to conduct your research. So for our research, our mostly in Malaysia, and I think in most of the most of the research in the world are following this empirical method. Okay. There might be some differences because in overseas, like in UK or France, you can see they have 6 or 7 chapters. For us, we have 5 chapters. All right. So we follow the UK system. So you can see that we have five chapters. Maybe I saw in Italy, I think Italy or France, they have 6 chapters, 6 or 7 chapters. I can't remember. So they might have some differences, but they are all following the empirical method. Okay. So if you can include some mathematical proof in your project, in your research, it will be more beneficial. Okay, it will make much more stronger for your research. Then so we can use theoretical methods, experiment, okay, and also simulations. Okay, so this is very important. How you want to do your research, you have to include, you have to mention in your methodology. Okay, so if you want to use if you want to explain your theories, okay, you have to explain in methodology. All the theories, calculations, formulas has to be explained, put into the methodology part. So methodology is the chapter where holds all your technical knowledge, how you want to conduct your research. Okay. So this is where you you prove how deep you understand about your project. So this is the methodology part. And so you can have theoretical methods, experimental, so you can do experiments. So first, before doing the experiments, you can do simulation. Okay. Artificial experiments, it's called as. So then deductive and inductive reasoning. Okay, so how you inductive means developing a new theory, coming out a new theory, because you don't have much literatures. Okay, let's say for example you have idea, but you don't have any literatures that available in that topic. So how to do your project? Okay, so you have to read other topics, other papers that are much more related to your topic. Then based on that, you need to create a new theory. Okay, new theory. So but it is very difficult for you guys to prove it lah, prove that your theory is correct, because when a deductive reasoning, deductive research is made on that, they can unproof. Okay, they can prove or unproof your theory. So for inductive method, it can never be fully proven. So you have to remember that it can be never fully proven. However, it can be invalidated. So we saw some examples, right, on that. So this is induction, induction, and also the repetitions and patterns. Okay. So when you collect data, you have to know the data that you collected is have some repetitions, or how the pattern is, the pattern of the data. So also you need to identify whether the data you collected is identical or is have some differences. So these are the important parts, important things that you have to know. So some of your research might need some identity, based on your results, but some of your research need some variations in your results. So this is based on your research lah, what kind of research you are doing. Okay. So these are the things. These are the very important things that you have to know for your research methodology lah. All right. So I think that's all for my part. So any questions so far? So I hope you guys understand. Okay. So I will upload these notes in the e-learning, and I'll upload the recorded video as well, so you guys can refer to the notes. Okay, refer to the notes and also lecture videos. So we will have some mini project for my part. But for this is like we call as mini project lah. It's not assignment. Because previously you guys did a presentation for the assignment, right? So you guys presented chapter 1. So chapter 2 is already done or not?
In progress. Supposed to submit, I think, on the 15th of June.
Okay, 15th of June. So you guys doing chapter 2, right? Okay. So then after that, for mini project, you guys will have combination of chapter 1, 2, and 3 lah. Okay. This is introduction part, introduction chapter, literature review chapter, and also the research methodology chapter. So I will upload the mini project rules and regulations. Okay. What you guys have to do, and also I will upload the rubric. So what is necessary to be in the thesis. So you guys only have to write up to methodology third chapter. If you guys are new students, so no need to be very very specific lah. Because you guys just doing the literature studies, right? So literature study itself, it will take some 3 to 6 months. So you guys can write based on what I thought, okay, for the methodology, and you guys have to do the presentation for the mini project. Okay, so that's for my part lah. All right. So any questions? If you don't have any questions, so thank you very much for attending the class today. So have a great day, and also have a great holiday. Thanks. Thank you very much.
Thank you, Doctor.
Thank you.
Okay, welcome.
Okay, thank you, Doctor.